All right, so today we're going to look at the other way to show electron arrangement for a quantum model. So up to this point, we've learned how to take orbital notation, which is the use of sublevels, orbitals, which are just simply blanks or spaces, and then arrows up and down, which are representing electrons. Now, electron configuration omits the arrows and the blanks from this process. So that's what we're going to focus in on today is this. It's kind of an abbreviated version of orbital notation. So I showed you guys this yesterday. This is the electron sublevel fill order diagram. All right, so right here, I've had this on the board this week where these are, or I had it on there last week and then yesterday. These are your sublevels, or excuse me, your energy shells. So you've got energy level 1, you've got energy level 2 with the 2s and 2p, energy level 3 with the 3s, 3p, and 3d, okay? And we learned yesterday, because I introduced to you guys the D sublevel, that you don't just get to always fill these, like you don't get to completely fill up energy level 3, all of its sublevels, and then move on to all of energy level 4. So the arrows that you see are the order in which electrons fill each sublevel. So, for instance, when we've been drawing orbital notation, we've written 1s and a blank, and then 2s and the blank, which is the orbital, 2p and the 3 blanks that go with it, all right? And then we go into energy level 3. And so this is what we've been doing, but we're not going to draw the blanks and arrows. We're simply going to write out the sublevels. So we're only going to focus on writing sublevels. We're no longer going to, and that again makes this different from orbital notation. This is electron configuration. It's quicker, all right? So it doesn't require as much work. So some of you may like it. I know I like it better. All right, so you've got 1s, right? And then you've got 2s. And then after 2s, we fill up 2p. And again, I'm just following these arrows, all right? You may or may not like this diagram. You don't have to use it. Actually, you can ignore it if you want to. So after 2p, we go to 3s. So this is like the order we've been doing things, right? So instead of arrows, we are writing the elements, the electrons as exponents, okay? So typically when we would write 1s, right, we would write a blank and then 2 arrows go in it. Well, you don't have to write that. You just write a 2 right here by the s as an exponent. So it's basically say in 1s, in sublevel 1s, there are 2 electrons, okay, total. And then in 2s, same thing. 2s is just 1 orbital. Remember, if it's an s orbital, if it's an s sublevel, it's got 1 orbital. If it's a p, it has 3 orbitals. If it's a d sublevel, it has 5 orbitals. And if it's an f sublevel, it has 7. And remember, each orbital can contain 2 electrons each. So that means that's 2 electrons total this can hold. The p sublevel can hold 6 total electrons. This can hold a total of 10, and this can hold a total of 14. So when we see this, so this would be 2 electrons, the p sublevel can hold up to 6. Okay, so I'm not sure what happened on my screen. I had to rewrite it all. So, all right, so, and then for 3s, it can hold up to 2, right? Because it's an s. So every s sublevel can hold up to 2 electrons. We've already learned this, okay? So, or each s sublevel, because it's only got 1 orbital. But a p sublevel, so like when we've written out 2p, we've always had 3 blanks, and it can hold up to 6 total electrons because it's got 3 orbitals, all right? So we see this here. So you should always, so you'll never see more than a 6 right here next to a p, all right? So electrons are exponents. So electrons are exponents in electron configuration. Okay, so now if I was to stop right here, just like in orbital notation, this right here is the electron configuration for a specific element. No other element has this electron configuration. So if I count up these exponents, that's 2 plus 2 is 4, plus 6 is 10, plus another 2 is 12. This is magnesium, which we were dealing magnesium yesterday in class, so I guess I kind of like using magnesium. But this would be magnesium because this represents the electron arrangement within sublevels. So in electron configuration, compared to orbital notation, we're just omitting this part where we're drawing out the electrons, like actually visualizing them within individual orbitals. All we're keeping is the sublevel and the total count of electrons within that sublevel. All right, so here's where it all comes together on the periodic table. And if I was going to give you a strong piece of advice, I would tell you that the periodic table is what you should use and rely on to do all of this stuff correctly. So it's essential and crucial that you learn how to do electrons arrangements by depending on the periodic table. All right, so if you don't have one near you, you don't want to have one handy during class, whether it's in a separate tab or window on your electronic device, your Chromebook or your MacBook, or if you don't have a paper copy with you, then you're wrong. All right, so just always make sure you have it. So this is going to make sense of why I have given you and shown you, and even in my classroom, you've got these letters, like you've got an S here, a D here, a P here, and an F labeled on the periodic table. It is actually labeling the sub-level blocks based on electron count. So don't forget that your atomic number is the electron count. In a ground state, free state atom, it's your electron count. So for instance, right here, this is aluminum. It has 13, its atomic number is 13. It's got 13 electrons. No other element on here has 13 elements in its ground state, or 13 electrons in its ground state. All right, so keep that in mind. And because of that, each element has its own unique electron configuration and orbital notation. All right, so we're going to take a look at this. This is really important, okay? So I'm going to use magnesium because I used it yesterday and I was just talking about it a minute ago. So magnesium is right here. It's number 12 on the periodic table. So magnesium has 12 electrons, all right? You don't even have to memorize the sublevel field. All you have to look at is the periodic table. So you can march through the periodic table and figure this out. So I'm going to take this. You see how it says 1s over here? Helium is actually, like, if we truly placed it, we would truly put helium right here. So we're just going to just say move this right here and pretend it's right here, okay? So if you start at number 1 on the periodic table, which is hydrogen, and then you go to helium, all right, that is your 1s sublevel block. Those are the first 2 electrons, those first 2 arrows we're always drawing, that's them right there. So you go 1s, all right? So you use the periodic table to kind of march through until you get to magnesium. So you're going left to right and down. So you're going weep, and then you go lithium, beryllium, boron. Okay, so you just continue on like that. So, and that's actually the order of your sublevel fields. So this is your S sublevel block. This is your D sublevel block. This is the P sublevel block. And this is the S sublevel block where you have your rare earth elements down here. Okay, so if I'm going to write out the electron configuration for magnesium, okay, the first thing I'm going to do is write my first sublevel, which is 1s, okay? That's what we always write first. And you can see I've got to go 1s, okay? Once I'm done with 1s, I'm done with the first period. So this is period 1, 2, 3, 4, 5, 6, 7, and each one of these represents an energy level. After 1s, there we are. We're done with 1s. Now we're going to 2s. All right? I'm going to put a 2 here and a 2 here. Why? Because those are electron counts. We know that 1s sublevel has 1 orbital and it can hold 2 electrons. And we're trying to get to 12 electrons. We're trying to get to magnesium's location on the periodic table. All right, so we've got 1s, 2s. All right, now don't come back over here. We've still got to go over here to the 2p section, right? So we go all the way through 2p. So you have to think that you can consider that each element block on the periodic table, each one of these little cells represents an electron. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so far. All right, now this is the 2p. That's 6 total, right? 1, 2, 3, 4, 5, 6. Which we already know that a p sublevel block holds up to 6. All right, because that's 3 orbitals, 2 electrons each. So we're at 1s2, 2s2, 2p6. So that puts me right here on the periodic table at neon, all right? But I got to keep going. So I start on my next row. Guess what the next row is? I talked to you guys about this a number of times now. Each row or each period you begin is a new energy level. So here we go. We're now in the 3s. And we are landing on right here. So this would be 3s1 again. So this is sodium. So if we were writing sodium, which is Na right here, it would be 3s1. But we are going to magnesium, so it would be 3s2. All right? So that is the electron configuration for magnesium. No other element has this electron configuration. All right, guys, now it's time to kind of practice and apply this on just a few more elements. So I'm going to do this, and then we'll get ready to wrap this up. Okay, so the first element up is carbon, all right? So if we find carbon, which is C on the table, it is right here. Now, what you need to understand is that it is in the P sublevel block. It's in the second period. So don't forget that your period number is like your energy shell, okay? So we can see that carbon is in the period 2 in P. And even in this, which I'm sure y'all will come to love this image right here, it's very helpful. You can see that carbon is in the second element, 1, 2, in the 2p section. So let me tell you this. If it is the second element in the 2p section, then you're going to know exactly where you should end up in your electron configuration. All right. So you're going to start with 1s because we always do. You're going to go, all right, 1s. Okay. And again, remember, we're pretending that this helium is over here. So we go through 1s, then we go through 2s, and then we go to 2p. So that's going to be 1s, 2, 2s, 2, 2p. And again, you might be going, why are you putting 2's there? Well, because an s sublevel has one orbital which holds 2 electrons. Don't forget that. So you've got an s, p, d, f. 1 orbital, 2 electrons. 3 orbitals, 6 electrons total. 5 orbitals, 10 electrons total. 7 orbitals, 14 electrons total. And what we're seeing is these electrons are essentially one of the elements on the periodic table. So we go through 1s, that's 1, 2. We go through hydrogen and helium, all right? That's 2. We go through 2s, that's 2 more. That's because each element is an atomic number increase, which is a proton count increase, which is an electron count increase. Then we go into here and we go to carbon, which is right here. So that's going to be 2p2. It is the second element in that 2p section. So carbon only has 6 total electrons, right? So that's 2, 4, 6. There's the 6 electrons that carbon possesses, all right? So you don't have to fill up, like, because we don't get, if we were going to write, if we were going to keep going and we went to nitrogen, it would be 2p3, 2p4, 2p5, 2p6. So each element is an electron count within that sublevel. So you really need to grasp and understand the fact that this right here, okay, and this right here, that last set of quantum numbers, all right, is important because it's like coordinates for where you can find that element on the periodic table. Carbon is in the second period. It's in the P section, and it's the second element over. So you look, you go, all right, here's the second period. Here's the P section, and it's the 1, 2 second element over in the P sublevel in that section of period 2. So this makes it very simple. If you don't rely on the periodic table to guide you through these, then you will get behind on this stuff. So it should all make sense. So next one, we are going to potassium. All right. So potassium is located right here. All right. So some things we can go ahead and see. We already know it's going to be the first element, okay, in the 4s block. So our last set of quantum numbers, which this is what I'm referring to, our last set of quantum numbers for this element should be 4s1. All right. So we're going to start with 1s, the first sublevel, 2 electrons, go to 2s, 2 electrons, then we're going to go through the 2p section, 2p6. Now, potassium has 19 electrons. That's its atomic number total, so we're working up to this. But we already know we're going to end up right here, which is 4s1. So we're just working our way up to it. So go 2p6, 3s2. Then we go through the 3p, 3p6. We go through all of these elements and those electron counts. And then we go to 4s and then 1. Now, a lot of students go, do I have to put the 1 here? Kind of like in algebra, I get what y'all are trying to do there. You absolutely have to put this right here, okay? You have to. You can't just leave it not there because you're just saying 4s. That 1 is important because it's representing 1 electron within that 4s, okay? I need to know that you guys know that. So, yes, you do have to put the 1 there. All right, so don't forget that is actually a location or coordinates for where you can find the periodic table, or excuse me, where you can find that element on the periodic table is by looking at that. So potassium is the only element that will end at 4s1. All right, so we go to cobalt. All right, so I want you guys to pay attention to this. Yesterday when I showed you the D sublevel and how it skips around, here's where it should make sense. So on my periodic table in my room, y'all may see that it says -1. Y'all may have thought this meant -1. But what that is to let you guys know that the D sublevel is always a period behind. So see how we are in period 4 right here? All right. 1, 2, 3, 4, 5, 6, 7. All right, so we are in period 4, but the D sublevel or section lags, okay? So it's always S and P are always on point. They are always in correspondence with the period, but the D sublevel block is not. Neither is the S sublevel block. More on that in a minute. It's actually 2 energy shells behind. All right, but when you enter 4, electrons will enter the 4s sublevel because, like I was saying yesterday, it actually requires a little less energy to be in the S sublevel block than the D sublevel block. So electrons will fill the 4s, then 3d, then 4p. This is crucial that you guys do not forget that the D sublevel block is 1 period behind. So it's always going to be lagging, all right? So don't forget that. It's 1 energy shell or 1 period behind. So for cobalt, cobalt is right here on the periodic table, okay? So it's going to end up in that D sublevel block. It's actually right here, okay, and group 9. So we're going to go 1s, 2, 2s, 2, all right? So 1s2, 2s2, 2p6, 3s2, 3p6, and then we are now entering period 4, so we go 4s2, and then we enter the 3d after 4s is filled, and we are 1, 2, 3, 4, 5, 6, 7, the 7th element in. So this is your electron configuration for cobalt. If you want to check your numbers, you can go, okay, I've got 2, 4, plus 6 is 10, 12, plus 6 is 18, plus 2 is 20, plus 7 is 27, and as you can see, cobalt's atomic number is 27, so we are correct. I keep doing that, my bad. All right, so cobalt ends in the... Now, this is where it might seem confusing. It's like, well, it's not in the 3rd period. Well, that's where you have to remember that the D sublevel block, if your element ends in the D sublevel block, it will be a period behind. Okay, so it's actually in 4. We have already opened up energy level 4. All right, and that's 1, 2, 3, 4, 5, 6, 7. And lastly, we'll do arsenic real quick. So you've got arsenic. I'm going to clean up the table a little bit. All right, so arsenic has 33 electrons. It is over here in the P sublevel block area. All right, so it's actually in our 4th period, and it's in the P sublevel block. So it's actually right here. So I can go ahead and mark that. All right, so here's arsenic. So I'm going to have to work through these sublevels. So the same thing. So I know I'm going to see cobalt was over here, so I know I'm going to at least get that far. So I'm just going to keep going because it gets repetitive, just like orbital notation. It's the same order every time. 3p6, 4s2. All right, so I'm going 1s, 2s, 2p6, 3s2, 3p6. Next row for S2, we go all the way through 3D. So this should make sense now because 3D, a D sublevel has 5 orbitals, right? So notice how the D sublevel block is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements or electrons long, all right? So this should make sense, all of this now. So a little bit clearer by using this periodic table. So we go through 3D10, all right, and then we get to 1, 2, 3. So we're the third element in. So this is going to be your last set of quantum numbers. You can see that arsenic is the 4p3 element on the table. And so you write all of this, okay, leading up to that last sublevel. So don't forget things like, you see these electrons that are highlighted in yellow within that sublevel. Those are your highest energy state electrons, okay? And some of the questions that I was asking you yesterday, I can still ask today, such as for cobalt, right? How many electrons are in p orbitals, right? So it's got 27 electrons. So how many electrons are in p orbitals? Well, you look at the p sublevels. You've got 1, you've got 2. So that's 6 here and 6 here, right? So that's 12 that are in p orbitals. I could ask you the same thing for arsenic. How many, or a different thing, I say how many of arsenic's electrons are in spherical shaped orbitals? Well, there's 2 here, 2 here, 2 here, 2 here, all right? So that's 2, 4, 6, 8, all right? So same sort of questions I can ask. It's just these don't have the orbitals and arrows, all right? And you just use the periodic table to guide you through each of these. And that is it. There will be a mini quiz to follow and some really important practice on Thursday over this stuff.